Welcome to CW 2.7. Today we're covering piecewise functions. So just highlight that topic right there. Piecewise function. What you want to do is focus right here. We call these fences, or I call them fences. That's really going to guide you as we're working through this, because notice how it says f of x is x plus 2 if x is less than or equal to 1, and it's 4 if x is greater than 1. So it's kind of like a computer program. It's saying if x is under 1, use this one. If it's bigger than 1, use this one. Now, for graphing, again, we're starting here, the fence. This 1 is your fence value. So I'm going to put a dotted line at 1 for you. And I recommend you do that too. Now understand, this is not an asymptote. That's a fence. That's just trying to help you graph it. And for doing this, you're always going to start at the fence. So put a big star here. Start at fence. It's going to help you graph. Notice how there are two regions we just created. Region 1, Region 2. Region 1 is everything left of 1. Region 2 is everything bigger than 1. So look here. That would mean this equation right here, that must go in region 1 because that's when x is less than 1. And this must be equation 2 or belong in region 2. So we start there. Notice how it's strictly greater than. So for this 4, all we're going to do is put an open circle at 4 and draw a horizontal line, because that's what the equation y equals 4 would look like. Now for this next one, x plus 2, we're starting at the fence, and notice how it's equal to. That means we want to plug in 1 here to actually get the value, so that would be 3. So we're going to close that dot right here, and now work backwards. I can see the slope here is 1, so let's go down 1 over 1, down 1 over 1, and then make your line, and look at that. A very nice graph, and that's why it's called a piecewise function, because the function is broken up into pieces like this. And this will always happen where one should be open and one should be closed. They both can't be closed because then it would no longer be a function. It would fail the vertical line test. Let's go to our next example. A little bit more complicated. So again, you want to highlight this stuff. These are your fences. And notice how there are two now. There's 0 and there's 5. So I'm going to put a dotted line at 0, like so, and a dotted line at 5. In your mind, you should understand that there are 3 regions, 1, 2, and 3, and you should assign them appropriately. Region 1 belongs to this first equation because it's less than 0. Region 2 is here. Region 3 is here. It's just a coincidence that these are happening in the order because I could easily mix these around. So don't get in the habit of making it 1, 2, 3. Purely a coincidence. So let's start by doing the easiest one. This is probably the easiest, 3, because that's a horizontal line. So we're going to go to 5, and we'll start at the fence. Go to 3, open circle, draw your arrow. Now think about why it's open. It's open because this is not equal to here. It's strictly greater than. So now let's do this middle one, 2x minus 1. And again, start at the fence. If I plug in 5 here, notice how you get 9? And 9's kind of off the graph. That's okay. Let's just go above it. It should be somewhere up here. And then plug in 0 here, we get negative 1. So I'm going to put an open circle because it's not equal to here. And let's just connect our lines. And yeah, that's pretty good. So there's our next line. It's a little bit off, but we'll just fill these points in to make it a little bit cleaner like that. Now the last part is x squared minus 1. Now this will be interesting because notice how this is equal to 0 here. And if I plug in 0, I get negative 1, which means this hole will get filled in by the other function. That does happen, and that's okay. Just fill it in. And it's a parabola, so keep plugging points. Negative 1 would be 0, and negative 2 would be 3. And sketch your parabola like that. And there it is. Now notice here there are a couple extra questions. It says f of negative 2. So you could look at your graph and see it's 3, or look over here. X is -2, which means we're in equation 1. You plug in -2 right there, that would be -2 squared minus 1. For 0, notice how you could plug in, though you see a 0 here and here, but you plug into this first one because it's equal to 0 here. So that would be -1. And for 5, again, you see a 5 here, but it says if x is greater than 5, equal to 5, we use this one. So plug in 5, we get 9. Now go to this last graph here. Same thing, look at your fences. This one's not too hard, we just see a 0. So put that down. Region 1, region 2. So once again, it's 1 and 2. That's pretty convenient. So graph regular x squared, and notice how it's equal to, which means I'm going to close this circle here, and I'll make my regular parabola points like that. Region 1 is done. Now region 2, negative x squared plus 4. Okay, that's interesting. That means if you plug in 0, you get 4. So there's an open circle at 4. And then plug in points for the rest. You can see if you plug in 1, you get 3. If you plug in 2, you get 0. So there's our other part of the graph. Pretty cool graph. Now we just plug in points to get the rest. F of -4, plug into your top one since that's a -4 and it's less than 0. That's 16. F of 0 would be 0. And f of 3, plug in 3 right here, -5. So that's a quick recap of piecewise functions. Now we're going to do something called the difference quotient. And this is super important for calculus especially. Part A says find f of x plus h. So you really got to think of this x plus h as like a thing together. Like imagine there's a box over it. Whenever you see an x here, just plug in the box. So it'll look like this. 2x plus h squared minus quantity x plus h plus 3. Now keep going. 2x squared plus 2xh plus h squared minus x minus h plus 3. This would be 2x squared plus 4xh plus 2h squared minus x minus h plus 3. So pretty long. This can't be reduced any further, and you leave it like that. Now B is the part that's a little more intense. B says find f of x plus h minus f of x and divide that by h. So think about why we did A first. We just found f of x plus h. That's this thing. So we're just going to plug that thing right here. 2x squared plus 4xh plus 2h squared minus x minus h plus 3. And this is the part people make mistakes. When you subtract the original function, you subtract the quantity. So subtract the whole thing. 2x squared minus x plus 3. That's important. And this is all over h, but let's reduce the algebra first. If you do it properly, a bunch of things should cancel out. So if I distribute that negative, I get -2x squared plus x minus 3. Notice how the 2x squared cancels out, this x cancels out, and the 3 cancels out. So all these things get knocked out. So we're left with 4xh plus 2h squared minus h all over h. So if you do this right, a bunch of things should cross out, and this bottom h is going to get simplified too, because notice how these all have an h in it. So let's divide everything by h. 4x plus 2h minus 1 is our final answer.